Hello, welcome to my channel. We are going to continue from where we stopped in the previous video. Remember, I'm treating 2014 JAMB past questions, and yesterday or in the previous video, I have discussed question 1 to 20. We've answered them with clear explanations. So today we are going to continue from question 21 then to question 42. Okay, meanwhile, I might leave some questions for you to try and give me feedback. If you are my student, I normally give assignments, on our WhatsApp channel, and you submit through WhatsApp. If you are not my student and are coming across this for the first time, I will explain later on how you can join us if you wish to. So please, I want you to uh, concentrate. Whatever you are doing, if you can just give this little time, I'm going to make sure that this video is as short as possible with clear explanations that will help you not just be able to answer this kind of questions, but any questions that will come around this topic. In the previous video, we have seen together, if you have watched it, how questions are being repeated in some topics, and I have shown you some of the structures and principles they follow in repeating questions. If you have not watched it, you can search for it on my channel, and I've arranged all the videos there in different playlists. You can go and watch them. So today we are going to continue from question 21 to where I will stop. I will ensure that it's as clear as possible today as usual. Please and please, if you cannot devote your time to really pay attention, I think you should just stop watching this video, because in learning, the principle is attention. If you cannot give attention, your brain cannot get anything. So if you know you are not ready to watch this video, I will just advise you should keep it. Later when you have time, come and watch it. But if you are fully ready, please devote all your time and watch it till the end. Get all that is. There is reason why I'm bringing these questions. I said it yesterday. If you are my student, you know how we normally do it. And I have told you that starting from yesterday, I will see how I can be posting videos. Seeing that JAMB is very close now, all you need to focus on now is past questions. Leave syllabus for now. The reason is because past questions, as you are studying them, they touch different categories of questions. So it means that you are learning from different topics as you go through the past questions. So if you are ready to continue watching this video, please let's go. Listen to all the explanations I'm going to give clearly. I'm not just answering questions. I try to give explanations around every question as much as possible, so that in case a question come close to what they have given in this year, you will still be able to answer. My goal is to have as many students as possible to emerge at the top. I want part of my students to be in the news this year among the top scorers in JAMB. And I tell you, I have amazing students on my WhatsApp group. They are just amazing. They are very good. And God is helping us. We are learning together on the platform. So follow me as we continue in today's physics continuation of what I started or of the previous video. Thank you very much, and let's go right into it. All right, so question 21 says heat transfer by convection in a liquid is due to what? Now, there are three forms of heat transfer. We have conduction, we have convection, and we have radiation. In case you don't know this before, you need to know this. Now, they are asking about the principle behind convection now, heat transfer by convection. Who knows this year? Maybe they will ask the principle behind heat transfer by radiation. Nobody. So, observe that they are asking key things. Principle. Do you actually know what is happening when heat is being transferred by convection? Do you actually know what is happening when heat is transferred by radiation? So it means that whatever you are learning, know the principle behind. I will always remember when I was on SciWest in one uh, general hospital. I happened to be in the diagnostic laboratory where they do tests. Now, the HOD there came one day and asked us, what's the principle behind the rapid test for malaria? You might be conversant or familiar with that cassette. It's something that anybody can do, even at home. all these pregnancy tests, all this, they can now do them everywhere. It's just to dip the strip. If it shows 2 line positive, it shows only 1 line negative. Now he asked us that principle, though we were able to answer, not very correctly, but at least we had the idea of about it. But he said something that struck my mind. He said, this is what differentiates you from a layman. He said, if I go to market now and pick a wheelbarrow pusher and bring him to the lab and tell him, okay, put blood sample in the blood window, put buffer in the buffer window, and allowed it for 5 minutes, then check if you see 2 line positive, 1 line negative. He said he will do it. Do you know that? We say yes, 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 sir. He said, okay, if anybody can do this, what now makes you different from them? So he was now trying to bring the idea. So this is the difference. Try and understand physics. It's very simple and interesting. All right, so back to this question very quickly. I'm just trying to explain this so that you will know what to know. Once you get this principle, I tell you, as far as studies is concerned, you don't have problem. All right, so I've said by conduction. By conduction, for example, if you put a frying pan on fire, if you touch the handle later, it will become hot. Do you get it? So it means heat has transferred from where the fire is burning down to the handle. That's by conduction, through particles that are packed together, solid particles. If you put an iron rod on fire, the same thing happens. By the time you touch the tip later, you find out that it is hot. Why? Because the heat has transferred by conduction, by a material medium, by conduction. So when we talk about convection now, we are talking about heat transfer by a liquid, most times by a liquid. So heat gets transferred by a liquid. Now they are asking us that what is the principle? Heat transfer by convection in liquid is due to what? How can you be boiling water here? Or let's say you put, example, electric heater. It starts when you plug an electric heater or what do we call it now? Okay, yes, let me use heater or kettle, electric kettle. By the time you on the socket and electricity flows through it, what happens first? The water at the bottom that is close to the uh to the source of heat is the one that will start becoming hot. Later on, the one at the top also becomes hot, and this is not conduction. So this is what we call convection. So what is the principle behind? So the correct answer here is D, the expansion of liquid as it is heated. So as liquids are heated, they are being as liquid as heated, they are being expanded, and as they expand, the density changes from heating, causing the fluid motion, causing the transfer of heat. All right, let's go to the next question. Question 22 says, okay, I didn't talk about radiation. I think I talk about, radiation without material medium. This time around, no material medium is required. On conduction, we have material medium, usually solid. On convection, we have material medium, usually liquids. But when we talk about radiation, there is no material medium. For example, microwave, or let me use an example, sun. When the sun comes out, you feel the heat here, despite the fact that the sun is several kilometers, millions of kilometers away from you, but you still feel the heat. How does it get to you? It's by radiation. This is a very good example. So I hope you get this. So let's continue to the next question. So the next question says, the distance between two successive crests of a wave is 15 centimeter and the velocity is 330 meters per second. Calculate the frequency. Oh, this is interesting. If you are my student and have watched the comprehensive video I made on waves, you will know answer to this question. I know you will know. That video was very comprehensive, and I got feedback from many students, both my students and those that watch it online. They have been just saying, God bless you, sir. This was very clear. In fact, someone say, I don't used to like physics in my school, but you have broke it down to the extent that I begin to love physics. I was so happy. So this question is very simple. Now, you need to know these simple formulas for calculating frequency, for calculating wavelength, and for calculating speed of wave. Very simple and very important. So here we are given the wavelength. Now observe here, they said the distance between two successive crests of a wave is 15 centimeter. What does that stand for? I explained this in detail in that video. You know, look at these people. Instead of them to say the wavelength, are you getting me? Because you know, the distance between one crest and another is what represents wavelength. So instead of them to directly say wavelength, they say no, the distance between two crests, successive crests. Can you imagine? Next time they may say the distance between two successive troughs. Can you see that? It's still wavelength too, but look at the way they used to. That's why that video has explained everything in detail. I talk about crest, I talk about troughs, I talk about wave speed, I talk about wave, in fact, speed in different mediums. Yeah. All right. So the formula for calculating our frequency is F is equal to V over lambda. V being the speed of the wave and lambda being our wave length. Don't forget this. This is the formula. And observe that from this formula, you would be able to calculate the speed and the lambda just by making whatever you're asked to calculate the subject of formula. All right, so substituting in this case, remember our, what do we call it? Our wavelength. Wavelength is usually in meters, but it is given in centimeters here, so you have to do a little conversion. So when you convert, it's just division. The speed is given as 300 divided by the wavelength in meters. And here I have 2000 hertz. That's the unit for frequency. Let me not dwell much on wave. I want to be as fast as possible. All right, so let's look at the next question. The next question says, a boy receives the echo of his clap reflected by a near hill 0.8 seconds later. How far is he from the hill? Okay, so a boy clapped his hand and after 0.8 seconds, he heard the echo of his clap. How far is he from the hill? Now, how do you calculate distance? Distance is speed times time. You have to know the formula. In wave also, that's what applies. So for him to have heard the echo, it means that the clap sound has gone and come back, and that's a round trip. So if we are actually to calculate the distance, from the distance between the boy and the hill, we only need one round. That's the going only. For it to go and come back, that's double. So that's not the exact distance. That's 2 times the distance because it goes first and it comes back. That's the echo. But now for us to get the exact distance between the boy and the hill, it just has to be a one-way only. So to get this is just to divide the time by 2. So to divide the time by 2 so that we can get the actual time we are supposed to use for the calculation. Is that clear? So, and that's why we say 0.8 divided by 2, and that gives us 0.4 seconds. So this is the exact time we need for the one round trip, not 2. I said it earlier. Now, remember our formula is speed times time. What is the speed? Now, observe that speed is not even given in this question. So, imagine you don't know the speed of sound in air. Hey, and this is a common thing. I remembered talking about this constants very well. I talk about them in one of the videos in physics or chemistry thereabouts. I laid emphasis. In fact, I've written some of them that you should know. So the speed of sound in air is 340 meters per second. Please know this. You may not know the speed in other materials like in other substances or materials like some metals. The speed may differ in some mediums, but then you need to know the speed of sound in air. Very important. Because you see, they did not give it here. If you don't know it, you can't answer this question. I tell you, you can't. You can only guess. And it will be better if you can answer it because you will joyfully leave the question to the next one, simply because you know that you got the answer correctly. Even you will be happy as you go through other questions. All right, let's go to question 24. An object is placed 10 meters away from a pinhole camera of length 25 centimeter. Calculate the linear magnification. Okay, this is optics. Yes, I wish I would have that liberty to do a video on optics, but no problem. As we continue to deal with past questions, I will be touching it. We'll be touching it. You can now see that we have cut across different topics since we started. That's the idea. At this point in time, this is what you need. You don't need to go and be looking for syllable by syllable. There is no time again for you. All right, so let's look at this question. So we are asked to calculate linear magnification. This also has to do with formula. For magnification, the formula is image distance over object distance. You have to know this formula also. So, and from this formula, you can calculate image distance if magnification is given. You can also calculate object distance if magnification and image distance are given. Just cross multiply, make the Pareto formula, and substitute. Simple. So at this case, we are just asked to calculate magnification, and we are given our distance, we are given our image distance and object distance. So the only thing you need to do is you change from centimeters to meters, because observe that the object distance is 10 meters, but the image distance is in centimeters. You have to be very, very careful about this. Please, I would advise, especially in physics, anytime you have a question, use SI units, the SI units. Please, that's what you should. All your values should be converted to SI units. Very important. If not, imagine someone will just come and say 25 divided by 10, and that will be wrong, because just simple changing it from meters to centimeters to meters. So always use the SI units. I have talked about SI units in a specific video. This is just to tell you that if not that I had limited time in the past due to my masters, I would have done an exhaustive work. And even now, some of the videos that I've done in the past, they are really rich. So I don't know how, if you are watching this for the first time and don't understand what I'm saying or don't know what I'm talking about, sincerely, you need to see those videos. They'll be very, very helpful for you in this year's exam. All right, so this is just division. If you divide, your answer is going to be 2.5 times 10 raised to power 2, or 0.025. Now observe something here. If you use your calculator, the final answer will be 0.025. But there is no option like that in this. So which means they also want you to know how to express decimals to standard form. Very important. Very important. So you have to know how to express them in standard form. I won't talk about that now because of time. I just want to be fast and treat these questions so that we can go. Please, you can find time to learn that. It's just simple. It's just simple. For example, look at our 0.025. If I'm to express it in standard form, I'll just move the decimal place. Look at where the decimal place is. So I'll move it to 0. Then I'll move it to 2. I will stop there. How many times did I move? Twice, right? Because you have to keep moving the decimal point until you reach a significant figure. So if I move once, it will be 0.25, which is not significant. 0 is the first number there. So I'll still move it twice, so that it will be 2.5 times 10 raised to power minus 2. Since I move it twice, it will be minus 2. If I move it 3 times, it will be minus 3, and so on and so forth. Please, I don't want to dwell much on that. Just create time to go and learn that. All right, so let's look at another question. The next question is still under optics. Talks about the focal length of a concave mirror is 2.0 centimeter. If an object is placed 8.0 centimeter from the image, the image is at, good. So this is still another question under optics, and let me tell you, just master this formula now. Just master this formula. Focal length, that's okay. Let me state the formula. It's there below. I believe you can see it. 1 over F is equal to 1 over U plus 1 over V. Very, very important. You can use this. In fact, hardly will they ask you a question that is outside this formula. You see the earlier formula, magnification, image distance over object distance, or this formula. Anytime they are asking question, most times it will be around here. Except in the case that maybe they will just ask, they may decide to ask, for example, object distance, in such a way that it's the same formula, but you need to rearrange, making the subject for formula. So know these two formulas as far as optics are concerned. Please, I beg you, know them. Very important. All right, so here we have the focal length, we have the object distance, where the object is placed, and then we are asked to calculate the image distance. Very important. So since all the values are given in centimeters, we can use them the way they are, all in centimeters, so we can use them the way they are. And we are calculating V now, so just substitute 1 over F. Our F now is 8. No, sorry, our F is 2. Is 2. That's the focal length. Yeah, focal length of a concave mirror is 2. So then we substitute it. So what I would advise is that just try and bring out your values, the values given to you separately. You label them appropriately. F is equal to this, V is equal to this, U is equal to this. Then it will be very easier for you to substitute them in the formula so that you will not swap them. Very important. So when you do the calculation, you find out that the final answer is 2.7 or 67, rather, approximately 2.7, because if you observe from the options, there is no 2.67, so approximately 2.7. All right, so let's go. 26A, in a compound microscope, the objective of the eyepiece focal lengths are, the objective and the eyepiece focal lengths are, so we are talking about microscope now. We are talking about compound microscope. You are all familiar with compound microscope. So we are talking about the objective and the eyepiece focal lengths. So what are they? At long infinity, long, short, the same. So the correct answer is that they are short, because compound microscope use short focal lengths for high magnification. You know what microscope does now? Something that is small, it magnifies it. So it uses short objective and eyepiece focal length. Okay, I hope this is also clear. 27 says, a telescope. When a telescope is in normal use, the final image is at dash. Now, do you observe that about 4 to 5 questions now, all under optics? Do you observe that? Do you also know that this telescope we are talking about is still under optics? It means that you should expect questions there. In fact, they would ask. But who knows where they will ask? So it means you need to really, and I hope my explanations are clear. So if they are not clear, the comment section is there. If you are my student in the group, yesterday I told you to drop your questions, watch the videos and drop your questions in the group. Let's discuss. I will not be giving you too many assignments now for you to be submitting to my DM because of time. So if anything is not clear, use the comment section and let me know. Excuse me, if you have been watching this video and you are not part of my group and you are interested, just write interested. I will see how I can add you. And most importantly, subscribe to this channel. I want to reach as many students as possible. Like, if you are learning something, don't like if you are not learning. No. If you are learning, like, drop your comments. Let me know. Are my explanations clear? Am I too fast? Yes, everybody has the pace or has the way they learn. So please, I want to get feedback truly from you, because I want to see how I can improve. I want to just give you the best. I want to be as clear as possible so that I won't be wasting my time talking and nobody is getting me. So I need that feedback. You can pause and drop the comment and continue. If you've not subscribed, hit the subscription button now. Thank you. All right, let's go. We are talking about telescope. So if it is in normal use, the final image is where? The final image is at infinity. In normal adjustment, the final image is at infinity for relaxed viewing. That's for telescope. You know telescope, or you've heard of it. Yeah. So there are those instruments they use to view objects in the space. very far distance. Okay, so question 28 says, when a negatively charged rod is brought near the cap of a charged gold leaf electroscope which has positive charges, the leaf dash. What does the leaf? Now, do you know what gold leaf electroscope is all about? Yeah, it is an instrument for testing the kind of charge an object has. Remember electrostatics? I have done a video exclusively on electrostatics and I talk about this gold leaf electroscope. I remember it was PowerPoint I did. In fact, I showed images in that PowerPoint where if you bring a negatively charged a negatively charged object close to a positively charged gold leaf electroscope, I show the images and I've explained clearly in that video. Do you now see how these lessons are very important to your JAMB? You are seeing the question here already. You are seeing the question. Though if you are my student and you have not watched those videos, I won't say anything. I know some of you are very serious. I know many of you have been following, but some of you, God will help you. And this thing is just for a time. Why not devote your time and learn now and just go through the university? Do you need to wait for the next cycle of admission, for God's sake? And do you just want to just pass? Just pass? No. I believe in excellence. I don't believe in mediocrity. I don't believe in average. So if you score average, I don't know. These things have their advantage. If you pass well in JAMB, I'm telling you, you will be bragging. Nobody will just look at any university would want to absorb you. They are also after the best, in case you don't know. No university want to have average students. No. That's why every year, if you observe the universities, anytime they do convocation, they normally publish the number of first class graduates they have graduated in each year. And the same thing also with my set. They published this thing. And they gave us Vice Chancellor's Award. I am an award winner, being the best graduating student from my department in my university. So, will it not be good? Won't your parents be happy? In fact, I know some of you, if you do well, your uncles will give you gifts. Even me, for my students, I've already announced that there will be a gift for my best candidates. I didn't announce what I'll give them yet, too. So, but I'm planning for that. So, if you are my student, you are watching this, okay, let me not say much. And remember, tomorrow by 10 p.m., we are going to have a knowledge sharing session. I am going to share some tips that helped me in the university to really have an edge. I remember in the last video, I think I have explained it. There were times that I was too choked up that I couldn't read for a subject, to the extent that I was to read it, I was to write the paper like tomorrow, because I used to be part of several university groups, both student union and university ethics committee, where I meet with several top university officials, more like representing students. So it has been I've been too busy in the university. Everyone knows those days. So, but there were strategies that have helped me to overcome and to get. In fact, that course that I had to read just a night before the exams, I had an A in it. I know that I've been reading for it. So this reading of a thing, I tell you, is a key, is a secret. Once you get it, you get it. All you need to do is to keep applying it, reapply it, improve it, and all your results will be in place. So that knowledge sharing session is going to be very, very educating. I'm just going to prepare you, help you, share some tips with you on how to learn fast when you have something to attend to, more like urgent, because I know time has gone already, and some of you are still left behind. Some of you still need to go through it. And even if you have gone through it again and again, you need to learn these tips. They will be very helpful for you now and later. So it's going to be tomorrow, 10 p.m. If you are not part of my student, you have to quickly reach out to me so that you can partake of this knowledge sharing session. So just don't forget to drop interested so that I can send you the WhatsApp link and you will join the group, because I'm going to drop the Google Meet link. We are going to have the meeting online. As usual, my student, we have different platforms that we use to meet. Google Meet, Microsoft Teams, WhatsApp. We have tried it. There is still another platform, Zoho, that I had wanted us to try. We have not tried that yet. Why I'm doing all this is just to get you conversant with the university. You don't need to just go to the university and be like Mumu in this era. In this era, some of the lecturers, they will be doing lectures through these online platforms. So once you know how to use them, you are conversant with them. Uh, your colleagues will be coming to you to help them connect. All right. So thank you very much. Let's go, please. Now this is how gold leaf electroscope works. If you don't know the basic law of electrostatics, there is problem. That basic law has helped me understand chemistry very, very well, and even many aspects of physics. What does that law say? Like charges repel, they repel. Unlike charges attract. Negative and positive, they attract. Positive and positive, they repel. Negative and negative, they repel. This is the working principle of gold leaf electroscope. Gold leaf electroscope is just an instrument that has more like a jar, and it has the two leaves inside like this. So, and it has the top where you can place the object you want to test. So the leaves are like this. I don't know if you can see my hand clearly. So let's say this gold leaf electroscope, they are charged. They are different. They have different charges. We have positive and negative charge. So if I have a positively charged gold leaf electroscope, listen to me carefully. Positive. The gold leaf electroscope is positively charged. Then I place an object that is also positively charged on the plate. That's positive gold leaf electroscope, positive object that I want to test. What will happen? Positive, positive, repel. So the gold leaf will diverge. It will diverge. But if it is positive and I place a negatively charged object at the top, that's unlike charges. And the rule says unlike charges attract. Are you getting me? Unlike charges attract. Positive, negative, they attract. So if you place a negatively charged object on a positively charged gold leaf electroscope, it will attract. I hope my explanation is as clear as possible. Hi, my people. Physics is interesting. In fact, science entirely. Chemistry, biology, physics. Oh my God. It's interesting, no? So now you can answer this question by yourself now. I'm not going to say the answer. Oh, they have seen it already. Hi. Why did I highlight all the answers now? All right, so let's confirm if my answer is correct. When a negatively charged rod is brought near a cap of a charged gold leaf electroscope which has positive charges, the leaf collapses. Collapse means it come together. It is like this before, so it collapses. All right, thank you. That's it attracts. Thank you. I have explained that very clear. If you don't understand that, I don't know. All right, question 29 says, what charge is stored in a 0.1 farad capacitor when a 10 volt supply is connected across it? So this has to do with charge. The formula for calculating charge is Q is equal to CV. Simple. I told someone before that JAMB don't even use to ask hard calculation questions. And the person was like, sir, do you mean it? Look at this now. Just multiplication. But if you don't know, there is problem. Some people will divide. Some people will just see the numbers and be looking at them. So you have to master some formulas. There are some basic formulas. You just need to master them. So you have to know that to calculate charge, you are going to say the capacitance of a capacitor multiplied by the voltage. That's just it. That's how you calculate charge. Okay, so here we have 0.1 times 10, and that gives us 1 coulomb. So it will store 1 coulomb charge. Let me not go far. Let me just, I hope these things are clear. You know the function of a capacitor, charge storage. Let me not talk much. Okay, question 30 says the maximum power transfer occur in a cell when the external resistance is. So when do you experience a maximum power transfer in a cell? When does charge transfer, power transfer becomes maximum in a cell? So the power transfer, for example, let's say you have a power bank and you want to charge. When does you have a high or maximum power transfer whereby the charge flow from your power bank to your phone? So you can experience a maximum power transfer when the resistance, okay, when the external resistance is the same with the internal resistance of the cell. That's when the resistance on your phone now, external, is, or on the cable you are using, is equal to the resistance of the cell. I will not talk about other options. Just get this. We are talking about maximum power. If the resistance of external, uh, uh, if the resistance of the external or the external device is greater than that of the cell, the power transfer will be low. That's just it. Okay. So 31 says a metal wire 4 meter long and a cross-sectional area of 0.2 millimeter square has a resistance of 6 ohms. Find the resistivity of the wire. So we're talking about resistivity. You can see that all this, we are talking about electronics now. We are talking about electronics. So the formula for resistivity is also given there. So we have resistivity is equal to resistance times area over length. Simple. Resistance, that's R, times area, A, all over length. And all these are given. Do you see it? All are given. All are given. But then you have to convert uh, the resistance, no, not the resistance, the cross-sectional area to meters. So you convert millimeter square to meters. So if you are converting millimeter to meters, you are going to divide by 1 million. Millimeters to meters, you divide by 1 million. So that will give you 0.8 times 10 raised to power minus 6. Then your resistance is 6 ohms, so it will be 6 times 0.8 times 10 raised to power minus 6, divide by, according to our formula, length. And length is given as 4 meters, so there is no need to change 4 meter. 4 meter is already in SI unit. I hope you observed that. But this area is not in SI unit, so we have to change it to meters too. Okay, so you get the final answer as 1.2 blah blah blah. Let me not. All right, 32. 32 says, maybe I will stop this video at this point so that we'll continue. It's already becoming long. We have up to 10 more questions. Can we answer all of them? Okay, let me see. Maybe I'll stop at a point if we cannot, because I don't want it to be long. So 32 says a circuit has a resistance of 200 ohms. The resistance of the circuit can be reduced to 120 when what? Okay, so if you are having a resistance, the formula we use for calculating a resistance when you have a parallel connection is 1 over R total is equal to 1 over R1, 1 over R2, 1 over R3, 1 over, depending on the number of resistors you have connected in parallel. I'm sure if you did physics very well, you know what I'm talking about. You know this formula. So if I now want it reduced to 120, that's the resistance, what do I do? So it means I need to connect it with, here I've already put the answer as 300, but how do you know that it's 300 if you want to reduce the resistance of the circuit to 120? So you are going to leave that blank. So our R total now, R total that we are after is 120 ohms. So it's going to be 120 is equal to 1 over 200 plus 1 over R2, which is unknown. Are you getting what I'm trying to say? Because we are given the total resistance we are expected to arrive at. That's 120 ohms. So, and you are given the resistance of the first resistor. So, if we want to now get the next resistance that is remaining for us to arrive at the total resistance, that will be the unknown. So, you manipulate the mathematics, and I believe you understand what I'm trying to say. I cannot be calculating 1 over 200 plus 1 over 300 for you. I hope you can do that. Yes. So you can confirm that. Oh, interesting. All right, next question 33. PHCN, Power Holding Company of Nigeria, measures its electric energy in kilowatts, of course. If you use prepaid meter, you will know this. Even if you don't use prepaid meter, you know. So electrical energy is commercially measured in kilowatts per hour. What's the best method to demagnetize a steel bar magnet? The best method, we have several methods of demagnetization: hammering, heating, rough handling. Rough handling, I'm not sure if rough handling is even a method of demagnetization, but JAMB brought it as an option. But I know heating, hammering, and solenoid method. Now they're asking which one is the best for steel bar magnet. So the correct answer is solenoid method. Solenoid method, you connect AC current decreasing to zero. It effectively demagnetized by random domains. All right, let's go. You see magnetism now. We have entered magnetism topic. 35. The magnitude of an angle of dip at the equator is what? We are still under the same magnetism. I hope you know that. Angle of dip. Okay. So at the equator, we are talking about at the equator, the magnetic field is horizontal. So the dip angle is 0. At the equator, the magnetic field is usually horizontal. So the angle of dip is usually 0. So B is our correct answer. 36. When an atom undergoes a beta decay, the atomic number of the nucleus. When an atom undergoes a beta decay, remember alpha decay, we are talking about radioactivity now. Alpha decay will lose a helium atom. So it will lose 2 protons, making the atomic number reduced by 2. So, but what of beta decay? Beta decay, that's an electron. So in beta decay, the atomic number increases by 1 because a neutron becomes a proton. So this is the correct answer. You know beta decay, you know alpha decay, you know gamma decay. In gamma decay is 0, 0. There is no loss, there is no gain, there is nothing. So you need to know this. Alpha decay, helium atom, the mass number 4 will be lost, the atomic number 2 will be lost. That's an atom of helium now. Is atomic number of helium not 2, mass number 4? That's why I'm saying it will lose a helium atom. I hope you understand what I mean. Okay, calculate the mass of a copper deposited during electrolysis when a current of 4 ampere passes through a copper salt for 2 hours. ECE of copper is 3.3 times 10 raised to power minus 7 kilogram per coulomb. Okay, that's the deposition coefficient. I don't know. Please note that electrolysis in chemistry differs a little from that of physics. Even their formulas are a bit different, but we are still talking about electrolysis, just that the parameters they use in measuring it differ a bit. So the formula for calculating mass deposited is equal to, we are talking about this question now, is equal to ZIT, where I is the current, T is the time, and Z is the coefficient. So this is just simple. It's just about multiplying because everything has been given already. So you multiply and get your final answer. Okay. So question 38. Which gas produces a pink-colored light in a discharge tube? You know discharge tube? Discharge tube looks like what do we call it? Sorry. Fluorescent lamp. So which one which one produces pink color? Is it mercury? Is it argon? Is it air? Is it neon? So the answer is air, because nitrogen component can produce pinkish hues in a discharge tube. Though neon is typically red-orange, so pink is usually for nitrogen, and we know that it's air that has nitrogen. Argon is already a gas by itself. 39. Yeah, we are close to finishing now. In a common emitter configuration, the output voltage is through the emitter. Please let me rush so that we can finish. You can just read this. If you are my student, please, one of you should remind me in the group so that I'll drop the material for you. It is still going to be very important if you have time to go through it. Just remind me in the group there, I'll drop it. Let's look at question 40. Question 40, here we have lead 21082 decays to 20680. It emits which kind of particle? Radioactivity. Do you see that I've already answered this question by the explanation I made previously? Just observe. By how much did the atomic number reduces? Because it decays from 82 to 80. Atomic number reduced by 2, which means it has lost 2 atomic number. Then the mass number reduced by 4. That's the helium atom I'm talking about. So, and this is always alpha decay. This is always alpha decay. You see, this is why sometimes I take my time to explain some things, because question may not come out directly. But if you really give time to listen to me carefully, you would observe that it will be very easier for you, because you would have mastered even some side things, so that if in case it comes, you will still be able to pass the question. All right. Oh, look at radioactivity. If I were you, I will know the questions to even concentrate on, the topics rather, because I'm seeing what they are doing. So what type of reaction is represented by the equation X2121 to give that N should be equal to, should be an arrow, because the reaction is, that N should be an arrow, please. Sorry for typo. Okay. So observe very well. X and X join together to produce Y and N plus energy. Observe the equation again. X plus X to produce Y. Now, X and X are smaller than Y, because Y has 2 and 3. Mass number 3, atomic number 2. Do you get what we are trying to say? So they are asking which type of reaction is this. Now there's what we call fusion. Fusion, F-U-S-I-O-N, that's B, means a smaller atom join with another smaller atom to form a bigger atom. This is exactly what is happening here. So it's fusion, coming together to form a bigger one. We have fission, a bigger one breaking to produce 2 smaller ones. All these are common reactions in radioactivity. Please, you can read further on that. This is the last question. A glass bottle of initial volume 2 times 10 raised to power 4 centimeter cube is heated from 20 degrees Celsius to 50 degrees Celsius. If linear expansivity of the glass is 9 times 10 raised to power minus 6 Kelvin per Kelvin, the volume of the bottle at 50 degrees Celsius is... So here we are asked about the volume expansion. Linear expansivity. You remember all these topics now in physics. So, and we have a formula to calculate this. So we are talking about changes in volume now. First of all, the changes in volume. So from 60, we have an initial volume of 2 times 10 raised to power 4 centimeter cube. That's the initial volume. Now, what will be the volume after the temperature has increased to 50? That's the question. Initial temperature, 20,000, I think, right? Yes, 20,000, because 2 times 10 raised to power 4 is 20,000. Yeah. So that's the initial temperature, the initial volume. But the temperature now increased to 50. What will be the final volume? So we have the formula. First of all, you have to calculate change in volume. Change in volume. If you calculate the change in volume and you got the answer, you now add it to the initial volume, and that gives you the final volume. So to calculate change in volume, you have to use this formula. Initial volume, which is V naught multiplied by 3 times the linear expansivity of glass times change in temperature. This is the formula you use to get change in volume. So this is just substitution. We have our initial volume as 2,000, which is 2 times 10, 20,000 rather, 2 times 10 raised to power 4, multiplied by 3 times our linear expansivity is already given as 9 times 10 raised to power minus 6 per Kelvin is there. Then multiplied by change in temperature, which is 50 minus 20, and that gives us 30. So the final answer will be 16.2 centimeter cube. This is the change in volume. So now what will be our new volume? Our new volume will now be 20,000 plus 16.2 centimeter cube. If you put it together, you are going to get 20,000 16.2 centimeter cube as the final answer. Thank you for staying through with me. If you have made it to this point, I think you deserve a clap. You know why? Many students have short attention span. They cannot stay for long to learn for long without distraction. And there is no way you can become an expert in anything if you have not mastered learning to stay. Very important, I tell you. I used to be like that too. I don't like routine. I cannot do one thing for long. No, I can't. But later I discovered that in this life, if you want to become an expert engineer, an expert nurse or doctor, medical doctor, or an expert whatever, you must learn to devote time to stay and learn. So if you have made it to this point, I really appreciate you. You see, you are not giving me the score, but I'm happy because I know that I have one student out there who is willing to learn, and I believe that I have not wasted my time. If you have not subscribed up to this point, I don't know what you are waiting for. Maybe you are not learning anything, but if you have learned something, subscribe. Go to the channel, check other videos. I'll be glad to rejoice with you if you are among my top students that score high marks. I'll be happy. You don't know how I've just been. Sometimes I just sit down and think and say, God, when will they write this JAMB? Let me begin to celebrate. Yeah, I want to hear good news. So, and for all my candidates, I'm praying for you. I'm doing my best to make sure that you get it all the best. Sorry, a few days I had to be away to attend to my dissertation. What do we call it? My dissertation research. I needed to create some documents ahead of my defense. And thank you all for your prayers. Remember, today is my birthday. Thank you everyone for celebrating me in the group there already. Today being 10th of April, I'm grateful for all the prayers you guys have prayed for me. I would really like to hear comments on the comment section. Please give me feedback. Like, subscribe, and give me feedback. If you are not getting it, let me know. If there is any question that is not clear from all my explanation, let me know. If you need to listen to this again, it is not a waste of time for you to play this video later from the beginning till the end. It is not a waste of time. It is better you understand something than to be rushing and you are not understanding rushing because you want to cover. It doesn't make sense. See, what I always do is that if I hold on a topic or if I hold on something, I make sure that I hold on until I understand it. I cannot go further. What's the essence of rushing, going, and you did not understand anything from the back? It's like building without having a solid foundation. You are rushing to raise the block. What will happen later? It will collapse. So thank you once again. I salute you. Let me know if you have watched to this point through the comment section. Thank you and God bless you all. Best wishes in your JAMB exams. God bless you.